For instance, there are a function like this. So it's simple. It's the the function is so simple like this. So now, if you want, so this is f of x, right? And right, and we always say this is x, right? There is no bracket, just x. So this is the line here is x, and the line here is fx. So if you want to know what is fx of x1, so the f of 1 is 1. If fx equals x, then f1 is equal 1, right? If fx equal x, then f1 is equal 1. If you want to know certain number output of x is easy. But if you want to take average number output of x sama dengan equals 1 until x equal 2 is easy. Equals number is fx, so the average is f1 minus, sorry, the n first, and then divide by the number of x, by the amount of x, in this case 2. So the average is equal to f2 is result 2, f1 is 1, and divided by 2, the amount of x is 2, because from 1 to 2, so count your finger, 1, 2, there are 2x, and the end the result is 1 minus 2 is equal 0.5. So that's it. So the average number of fx, so let me see, let me reduce the thickness, the size of the line. So for instance, this is 1 and this is 2, and you want to average the number. So you want to average the number of fx. Well, for instance, this is also 1. No, not for instance, this is also, so I add the function, so you might getting clear that the average is 2. So if I want to take, so the average, the average uh average, so if you the, so averaging something with something averaging something is usually used in velocity measurement. So for instance, the x, we have new name for the horizontal line is distance. So we have new name of the horizontal line is distance in meter. So give your a unit standard unit, I mean m, and we have new name for fx. It is time, yes, and give your measurement units is, and give your units is s, so time s, and we have new name for fx. So let's destroy this, let's erase this fx, so let's erase this and erase x, pretend that you don't see this, or maybe we could erase this, and sorry the DL, so disturb so you see that the graphic is changed in the way you is now more beautiful. So you get a new name, you get more beautiful. So if I want to measure the velocity uh is agreed uh, agreement is total distance over total time. So that's velocity. So if you see that there the velocity formula here uh, is is similar to the here the average of one point to another point. If you see this, you will there are it will looks it will looks like, if you want to measure between the velocity of a car from the method 1 and method 2, from the method 1 and method 2. So this is a road, this is a road, so this is a road that I've fixed it. So this is a road, for instance. So this is the 1 meter and this is the 2 meters. You want to measure the distance, the speed of the car from the, so this is, pretend this is a stone that that have information 1 meter, and this is another stones that have information written on that stone is 2 meters. So you want to measure between the stone. So what you will do is similar like you do in here in a graphic. Is finding the distance 1 meter and get the time. Finding the 2 meter and get the time is 2 seconds. So 2 seconds. 1 minus 2. So this is not the amount of x, I think so. The average is 2 minus 1. So this I should press this 2 minus 1. So x2 minus x1. So if that's correct, so you will get the total distance is 2 minus 1 is 1, and the total time, so per total time, so total time is 2 minus 1 also is 1 also. So velocity is total distance, in this case 1, and total time, in this case 1. So 1 per 1 is equal to 1. So you get this one. Okay, that's but the problem arises when you want to measure the instantaneous velocity. There's a fancy word to say that if you want to measure the truly speed at very so forget this line, at the very 1 meters, you will get so let's see, 1 meter minus 1 is 0, and 1 meter and this one 1 meter over 1 meter 1 meter minus 1 meter is 0 also, and 0 divided by 0 undefined. So let's say 0 divided by 0 is undefined. Let me do that again. 0 divided by 0 and click sum, result as is undefined. So that's a problem. So we cannot measure a instantaneous velocity at certain point. So it's not we cannot measure that. The reason is, the answer is we can, but we want to very limit. So instead of 1 minus 1, you just 1 minus 0.99. So this, it's very close. You can add, so the 0.99 is 0.111. Okay, the result is 0.111. Let me check that on my calculator first. 1 minus 0. How many 9? Well, how many times 9s we got there? We have D here. So 1, 2, 3, 4. 1, 2, 3, 4. So there are 1, 2, 1, 2, and 3, 4. So the result is 0.001. So it is wrong. The result is 0.001. So how many 0 behind the floating point or the comma? 1, 2, 3.